Hello again, everyone. In this lecture, I'm going to do another example problem with using Coulomb's law to calculate the force on a charge due to other charges. And this will be the last lecture from chapter 21. So hopefully then you have enough information, enough stuff to actually go ahead and do the homework assignment and reading quiz, etc. from chapter 21. So let me go ahead and start here. So example 2, in this example, what we're going to do is we're going to look at three charges placed at the corners of a triangle, basically. So Q1 is over here, plus 2 microcoulombs. Micro is 10 to the negative 6 coulombs. It's 3 centimeters away along the x-axis from Q2, which is negative 1 microcoulombs. And then the charge that we're interested in as far as the force goes is Q3, 2 centimeters above Q2, and it has a charge of negative 5 microcoulombs. So I just want to calculate the net force on Q3 from the other two charges, Q1 and Q2. As any force goes, they are vectors. So I'm going to end up having to deal with the force from Q1 acting on Q3 plus the force from Q2 acting on Q3 and add those together as vectors. And so let's look at the two forces. First of all, F13 from Q1 on Q3, well, they are opposite charges, plus 2 microcoulombs and negative 5 microcoulombs. So the force on Q3 is going to be attractive. It's going to point down toward Q1, right? And of course, since it's a vector, it's going to have an x component and a y component. Both of those are actually going to be negative, you can see here. And I'm going to define this angle theta to be from this x direction down to the direction of the force, F13. Now, F23 is simpler because it only has a y component, right? Negative 1 microcoulomb charge for Q2, negative for Q3. They are like charges. They are going to repel. So the force on Q3 is going to be upward, away from Q2. And since they're along that y-axis, it only has a y component. So now that we've got the direction of the forces down, we can go ahead and start to calculate the components of the forces, right? Whenever we add vectors, we have to calculate their components, x and y, and then add the components together. Well, let's start with F23. Since it's simpler, it only has one component. And so it only has a j hat component, right? But we use Coulomb's law to calculate the magnitude. In this case, Q2 times Q3, those are the two charges, over R23 squared. So R23 is just the distance between the two charges, which is my 2 centimeters right here. So plugging those numbers in, it's in the positive y j hat direction. I actually get a magnitude for F23 or F23 vector force is 112.5 newtons, j hat in the y direction. Okay, so again, I just use Coulomb's law to calculate the magnitude and use the rule that opposite charges attract, like charges repel to get the direction of that force. So let's go ahead and move on to the other force, F13. Now it's trickier. It's got two components, right? It's got my negative x component, negative I hat, as well as a negative y component, negative j hat. To get those components, I've got to multiply my Coulomb's expression, kq1 q3 over r13 squared, by the cosine of theta, right? This is the adjacent side. So use cosine theta for the x component and sine of theta for the y component. It's the opposite side to that theta angle there. Okay, so that gives me the general expression for how to calculate the components. So notice the magnitude is the same. It's just Coulomb's law, kq1 q3 over r13 squared, kq13 over r13 squared. I just have to multiply by my sine or cosine, depending on whether I want the x or the y component of that force. So to calculate this now, I need to be able to calculate the cosine, the sine, and R13. And to do that, I'm just going to use some geometry here. So for R13 is this whole distance between Q1 and Q3. Well, it's the hypotenuse of a triangle with sides of 3 centimeters and 2 centimeters. So I can just use Pythagoras' theorem for that. Right, and so square root of 3 squared plus 2 squared, I get 3.61. This should actually be centimeters here. But of course, when I calculate the number, I got to change this into meters. So there's my distance between the charges. What about the cosine and the sine? Well, if I look at cosine of theta, theta is up here, but we'll notice that it's equal to this angle, right? These two angles are equal, so cosine of theta is adjacent side 3 centimeters over the hypotenuse, which is R13. So I end up with 3 over square root of 3 squared plus 2 squared gives me 0.831. For the sine, it's just that I use the opposite side over the hypotenuse, so 2 centimeters over square root of 3 squared plus 2 squared, and I get 0.554. All right, so plugging all of this stuff in, I end up getting this big expression here. And again, I have to remember to change when I put this in my calculator from centimeters to meters. So this would be 0.0361. I plug it in, but I've got my cosine theta, my sine theta. I've plugged in all of my numbers, my K value from Coulomb's law, and I can calculate the force here. So I end up with negative 57.4 newtons as the X component, I hat, negative 38.3 newtons, J hat. Okay, so now the last step here, I've got the two forces acting on charge 3. I need to add these together. So notice that when I add, there is no I hat for F23. So I'm just going to add 0 plus negative 57.4 newtons. And that's my X component, right? I just add the I hats or the X components together. And then I add the J hats or the Y components, 112.5 plus negative 38.3. That gives me 74.2 newtons for my Y component. And so again, I've added the two forces as components, as vectors, and I got that force, well here, I guess I actually wrote it down, negative 57.4 newtons I hat minus 38.3 newtons J hat, which is F13, plus my F23, which only has the J hat component. So only these two numbers add together, and I get finally my expression for the components of the force, negative 57.4 newtons I hat plus 74 newtons J hat. Okay, so that, I'm basically done. That's the force on Q3, but sometimes, of course, you're asked, what is the actual magnitude of the force, right? And again, by the magnitude, I mean the length of the vector, basically. So in that case, the components form the X and Y sides of the triangle, and I can just use Pythagoras' theorem with those to get the magnitude. Square root of the X component squared plus the Y component squared, I get 93.8 newtons. And so just to kind of draw this, I added F13 and F23, right? And I got a vector over here. It kind of makes sense, right? I'm adding the two vectors, or net pole is in this direction. Negative 7.4 newtons is the X component of this force vector. 74.2 is the Y component. So I just use Pythagoras' theorem to get the hypotenuse or the magnitude. I could use trigonometry too to get the angle or the direction if I wanted as well. Okay, so hopefully that will show you that as an example of basically what I'm going to do with the force law, with Coulomb's law, to calculate the force between two charges. I could have more than two, right? I could have a whole bunch of charges along here, and I just have to add up the force vector from each of those charges on the charge that I'm interested in. Okay, so for right now, that's the last lecture for chapter 21, and we'll see you soon.